In this video, I'm going to show you how to construct a confidence interval for a population mean when the population standard deviation is known. This procedure has two requirements. The first requirement is that you have a good sample, which is a simple random sample. And if you're doing, homework questions or textbook questions, this might be assumed. However, if you're doing like a test lab or lab question, you might need to really verify your sampling methods. Next, you need to make sure your sample size is large enough so that the central limit theorem applies. That would be a sample size of at least 30 items, or you have to know that your population is approximately normally distributed. Given either of those two scenarios, you will satisfy requirement 2 and you'll be able to proceed with the procedure. Here's the procedure for computing the confidence interval. We're going to find the value of the point estimate. If it's not given, that's going to be the sample mean. We're going to find the critical values, and these are going to come from the normal distribution. Take note of the Z alpha divided by 2. We're going to do it with technology. Then we're going to find the standard error and multiply it by the critical value to obtain the margin of error, at which point we'll be able to create the confidence intervals in any format that you need. Here's the question that we're going to look at. The weight of a diamond is measured in carats. A random sample of 18 diamonds in a retail store had a mean weight of 1.08 carats. It is reasonable to assume that the population of diamond weights is approximately normal with population standard deviation 0.12 carats. Is it appropriate to use the methods of this section to construct a confidence interval for the mean weight of diamonds at the store? So we want to look to see if the requirements are met, and then if they are met, we're going to construct the confidence interval, and we're going to do it at a level of 95%. In terms of the first, we're told that we have a random sample, and so we can assume, again, it's a simple random sample because this is a textbook question. Now, the second requirement is about the size. The size is 18, which is less than 30, but we're also told that it's reasonable to assume the population weights is approximately normal. So even though the sample size is small, the population is approximately normal, so we're able to proceed. The point estimate is X bar equal to 1.08 carats. I'm giving you an alpha equal to 0.05% from a confidence level of 0.95. It could typically 99 or 90, just depends on what the question gives you. This question doesn't, I'm giving you this. So now we want to compute Z alpha divided by 2. So remember, the picture of this is that we have approximately normal distribution, and that alpha is split evenly in the two tails. And so this is alpha divided by 2, this is alpha divided by 2. And the Z values here are the critical values. So we're going to use technology to find that. The technology I'm going to use is Desmos. There. And we need the normal distribution. Desmos has a command that we can find the bounds. And I want the outer area to be 0.05. This gives me the following critical numbers: 1.960. That's our Z alpha. So now what we're going to do is we're going to compute the the margin of error. And to do that, we're going to take the population standard deviation divided by the square root of the sample size. And that's going to be the standard error. And then we're going to compute multiply by the margin of error. Multiply by the Z value to get the margin of error. Depending on what your instructor might allow, we could do this in one step or we can do this in two steps. So I'll show you both. Let's see. From the question, the standard deviation is 0.12 carats. And n is equal to 18. So 0.12 divided by the square root of 18, that is the standard error. If I multiply it by my z value, I'll have the margin of error. Now, I'm not going to do any intermediate multiplication, so I'm just going to retype in this calculation, and this is my margin of error. So if you need to show both of those ever, that's how you would show both of them. I'm going to grab a screenshot and put the screenshot on into our work. And now we're ready for the confidence interval. I'll label these for you. So the confidence interval is just going to be the point estimate plus or minus the margin of error. The point estimate was 1.08. So plus or minus 0.06, we're rounding in kind. So you will add and you will subtract that from the point estimate. I'll show you one more thing you can do in Desmos to help you save this work. Let's call this M. Let's give it a name. And so I can do 1.08 plus M and 1.08 minus M. And these are the values that I get for my confidence interval. For rounding in kind to what we have, I have the upper interval. Well, let me do it in order. So for the lower interval, 0, 2. And then for the upper, 1.14. The units are carats. Another way that you can write this is with the inequality notation. So 1.02 is less than the population mean, less than 1.14. All of these units are carats. And these are all the ways that you can write the answer. Let me know if you have any questions. You can sound off in the chat.